Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Trigonometric Function Basics, Unit Circle, Radius Measurement. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is so effective. I'm coaching you to turn your wants and desires of getting an A or perfect test score into a new paradigm. I want to include everyone who needs a boost in Algebra 2. If I could stick every math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. You have lots of peers, classmates, and colleagues who need to cram for Algebra 2 as well. So inbox me at memedicine@gmail.com to order this complete cram session. Be sure to spread the word to them as well, to inbox me at memedicine@gmail.com so that they too can order this complete cram session. You'll want for them, that is your colleagues, classmates, and peers, to have this knowledge because they'll make great study buddies. The concept of cramming often has a negative connotation, but what people are actually thinking of is hurrying, which is a result of fear and it's consequently destructive. We're not hurrying here, okay? There's a difference. We're cramming. Hurrying is jam-packing tons of unorganized information into your mental, spiritual DNA over a tiny amount of elapsed time, whereas cramming is taking quantum leaps in your understanding in an organized way that seems to have occurred over an instant. Let's delve into the concept of the unit circle with regard to its radius measurement. Trigonometric values and the unit circle. What is the length of the radius of the unit circle? Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you are able to explain or draw out your answer. And the answer is simply 1, hence the name unit circle. The measurement of the radius in any direction of a unit circle is going to be 1 unit, okay? And we see here that this inscribed line segment that intersects the circle is forming an angle that's in standard position. When I say standard position, the vertex of the angle is at 0, the origin. The initial side ray is on the positive x-axis, and the terminal side ray, or the hypotenuse, or the radius of the unit circle, ends here, okay? Forming this acute angle in standard position. Well, what would this mean if the radius fell at the boundaries of the quadrants? Well, here the x-coordinate is 1, the y-coordinate is 0, hence a measurement of 1. At the boundary of quadrant 1 and quadrant 2, you have the x value is 0 and the y-coordinate is 1. Again, hence a radius measurement of 1. At the boundary of quadrant 2 and 3, you have an x-coordinate of -1 and a y-coordinate of 0. Hence, the measurement of the radius is also 1. Because you have to remember, you use the distance formula to measure the radius, and since it's squared, it doesn't matter that this is -1 because -1 squared within the distance formula is going to yield a positive measurement, okay? And again, at the boundary of quadrants 3 and 4, the x-coordinate is 0 and the y-coordinate is -1, hence a radius measurement of 1.